So then I have problems from those. Yeah, you can probably verbalize these, I suspect. I got the thing that looks like a big E is called sigma, right? Okay. Is that right? Yep, that's what that's called. So, would you read it top to bottom? Bottom to top. Alright. So J equals 1. And then the right side, 6 over J squared. What's the top of sigma? J equals 1 to what? The very top is 4. Okay. So that's the way you describe that. Is we're going to take the sigma of 6 over J squared, where J is going to go from 1 to 4. And what do they want to know? Find the sum. Find the sum? Okay. Give me the first term. In other words, this is going to equal to 4 terms added together. What's the first term? Is it 4? Plug in 1 for J. Always start at the bottom and work towards the top. Then it would just be 6. 6 over 1. What's the second term? You go up by 4? No. Go one integer at a time. In other words, the second term is J equals 2. 6 over 4, because it's J squared. What's the third term? 6 over 9. And the fourth term? 6 over 16. Whatever that equals is your answer. Now, those fractions aren't that easy to deal with. Let's see if we reduce them, whether it makes it any easier. Makes it a little easier. The top tells you how many times to do it? No, the way you interpret this is the first term is when J equals 1. The second term is when J equals 2. Third term, J equals 3. Fourth term, J equals 4. And then it's the sum of those 4 terms. What sigma means is sum. Okay, so you know there's 4 terms. We're going to just add the 4 terms together. Now, this is just not that hard of algebra. What's the common denominator, the least common denominator going to be? 6. You could leave the 6 alone for a second and just add the 3 fractions. What's the least common denominator for those 3 fractions? 24. Okay, so now we got 6 plus how many 24ths is 3 halves equal to? 32. 36. Plus 2/3 is how many 24ths? 16. And 3/8 is how many 24ths? 9. Now we can just add the numerators. And we get 52, 61 24ths. And now we want to simplify that a little bit. I can pull 48 24ths out of there. So I end up with 8 and 13/24. You see how I got that?
Yeah.
Okay, good. All right, what else you got?
I'm going to do one more of those.
Okay.
So I equals 1. And then on the right, I over I plus 1. And on the top is 8.
I equals 8. How many terms?
These don't show an I equals, they just show a number.
Oh, so they just write it like that. Oh, that's what it means. It means I goes from 1 to 8. Okay, how many terms are going to be in this sequence?
8.
Okay, give them to me. What's the first one?
1/2.
Second one?
2/3.
Third one?
3/4.
Notice the pattern.
4/5.
You can, yeah, at this point you can stop thinking and just follow the pattern.
Yeah.
And just make sure you write 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then don't worry about solving that. They're not ever going to ask you to do that.
Okay.
In other words, well, I'm not sure actually what they're looking for as an answer. You could give them that as an answer, and that would be correct. Okay? Yeah, they don't want you to find the least common denominator here is going to be enormously large. And then when you convert each fraction to that least common denominator, there's a lot of arithmetic involved there. So it would take us another 10 minutes to find the least common denominator and figure out what the final fraction is. And that's not their point. Their point is not to test your algebra skills. Their point is to make sure you get all 8 terms properly. And that's all you do here. And incidentally, when you're describing these vertically, describe that first. It is sigma of I going from 1 to 8 of I divided by I plus 1 is the way I would verbalize that. In other words, you don't want to give this and then this and then that. It's kind of out of order. Always give the full left side of the sigma. Now, sometimes these sigmas go to infinity, like that.
Yeah.
Okay, something like this. Or, excuse me, 1 over I. If you just look at, this is an extremely interesting series. Let's just talk about it for a second because it's so significant. Let's make it n so we're not confusing 1 with I. Okay? Let's say we had that series. What's that series equal to? Start giving me the terms.
That's equal to 1 over infinity.
Hold on. Let's do it one term at a time. First term is 1. Second term.
1/2.
Third term.
1/3.
That actually goes to infinity. Believe it or not, that's an infinite series. In other words, if I add up all the terms, all infinite number of them, I get infinity. Okay? But here's a huge difference. If I make it n squared in the bottom, Now my term is 1 plus 1/4 plus 1/8 plus 1/16 plus 1/32. Believe it or not, even though that goes all the way to infinity, the sum is not equal to infinity. The sum is equal to 1/2. All of this adds to 1/2. And the only thing you need to convince you of that is to take a square and start dividing it up. Well, there's 1/2 of the square. Hold on. Divide that part up, that's 1/4. Divide that in half, that's 1/8. Divide that in half, that's 1/16. Divide that in half, that's 1/32. So you can see that 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus all the rest of this adds to 1.
Yeah.
So infinite series are a fascinating topic to learn about because some converge to a real number and others diverge to infinity. And this is a case where 1 over n squared converges to a real number, whereas 1 over n just goes to infinity. And yet they look very much the same. In other words, if I said, here's what goes to 1. Okay? If I go all the way to infinity, that series adds to 1. But if I take this series, this does not converge to 1. This goes to infinity, believe it or not. Very hard thing to understand why the top series converges to the number 1 and the bottom series goes all the way to infinity.
So, an example problem they give is it says find the sum of the infinite series is sigma I equals 1 to infinity of 5 over 10i times 2 to the I.
5 over 10i, is that it?
Times 2 to the I.
Times 2 to the I?
No, 10 is to the I power.
In other words, this whole thing to the I power like this?
No, there, just on the bottom, the 10 is to the I power.
Oh, now I get you. Okay. So it's this, like that.
Yeah.
Well, let's write out the first few terms. That's, if you don't know what to do, that's never a bad start, is to write out the first few terms. What's the first term?
5 over 10, so...
What's the second term?
5 over 100.
And the third term?
5 over 1,000.
Notice what we're looking at. We're looking at 0.5 plus 0.05 plus 0.005 plus 0.0005. What number are we going to get in the end?
Are we just going to get 0.0155 repeating?
This is what we'll get.
So you should put the line over it.
Right. But what fraction is that? I think that's, what is that? Is that 5/9? I think it is, 5/9. In other words, if I divide 9 into 5, I get 5 and 5, 5, 5, 5, 5. So if I wanted to write 5/9 as an infinite series, that's it right there. That's 5/9. And that's its sum. In other words, if I sum up all infinite number of terms, I get this down here, right?
Yeah.
First of all, make sure you see that. In other words, 0.5 plus 0.05 plus 0.005 gives you 0.555555 forever. That is the same as 5/9.
Yeah.
Okay, what else you got?
Okay, so this next one, find a formula for A sub n for the arithmetic sequence. The A to first equals A sub 1 equals 7, D equals 12.
What's the general formula for the nth term of an arithmetic sequence?
B parentheses n minus 1.
Always start out with the first term. In other words, yeah, it's really this, okay? Now, you can switch these two. There's nothing wrong with your answer you were giving me. It's just a little easier to remember these sequences, these formulas, if the first term is always the first term. That's the first thing you always want to write, okay? So if this is the general equation for the nth term of any sequence, well, what's the nth term of this particular sequence?
It's just 7 plus 12 and minus 12.
Yeah, and you always want to reduce these. So 7 plus 12n minus 12, but you can keep simplifying that. What does that become?
12n plus 5.
Minus 5. So that's what the nth term is. In other words, if I wanted to know the 175th term, I could figure it out real easily by just plugging in n of 175.
And D is the common difference, right?
Correct.
All right, and then one more.
In other words, if I were to want to write this sequence out, well, the first term's 7. They tell me a sub 1 is 7. Common difference is 12, meaning the second term is 12 more than the first. Third term is 12 more than the second. Fourth term is 12 more than the third. And so forth and so on. But if I wanted to figure out the 175th term, it'd be tough to do it this way. I'd still be doing it an hour from now. Whereas if I know this, then I can just plug in 175 for n and have it near instantly. 12 times 175 minus 5.
Yeah.
That's the beauty of these formulas, is that you can figure out a big nth term without having to do it manually. All right. What else you got?
It's the same question.
That's okay. Let's do it.
A sub 7 equals 8.
Hold it. What?
And then A sub 7 equals 8. And A sub 13 equals 6.
All right. Now this is a little tougher because they don't give you a sub 1. In other words, this is our general formula. Well, what these two pieces of information are going to allow you to do is write two equations. Well, a sub 7 which is equal to 8, is going to be equal to a sub 1. I still don't know the common difference, but in this case, n is 7, so I get that. You with me?
Yep.
Now, a sub 13 is equal to 6, because they said it was, and that's going to be equal to a sub 1 plus the common difference, which I still don't know, times 12, because it's n minus 1. Well, now I have those two equations. There's only two unknowns. I'm going to be able to solve for a sub 1 and d. So what's the best way to solve that system of equations right there?
I would just multiply the bottom by -1.
All right. You know what, Max? You can subtract equations just as easily as add. So I don't need to do that step. In other words, instead of setting it up so that I can add the equations to get rid of a variable, let's just subtract. Let's subtract the second one from the first one. What do you get?
You get 2 equals d
What's 6d minus 12d?
6d minus 12. It's just the -6d.
Minus 6d. So we can solve for d. Now I can go back up into either equation and solve for a sub 1. In other words, if d equals minus 1/3, then 8 equals a sub 1 plus a minus 1/3 times 6, which is minus 2, so a sub 1 equals 10. Now I have my nth term. I've solved for a sub 1, which is 10. I've solved for d, which is minus 1/3, and the rest is n minus 1. So that is my nth term equation for this particular arithmetic series. Remember, every arithmetic series is going to have its own specific equation. Now, I could simplify this. I need to distribute the 1/3 to both of these terms and then simplify. But basically, that's how I solve these, where they give you a term, they give you two different terms, but they don't give you d and they don't give you a sub 1. Well, the way you solve it is exactly what I did here. In other words, I use my definition. In other words, we know that a sub n is always equal to a sub 1 plus d times n minus 1. So they told me what a sub 7 was, is 8. So I can put 8 there, and I can put 7 for n. And that's where I get that first equation, which was a sub 1 plus 6d. And I do the same thing for the second, and I get 6 equals a sub 1 plus 12d. And then, as long as you have the same number of equations as you have variables, you can always solve it. Well, not always, but most of the time. Problems like this, you're always going to be able to solve it. In other words, when they're talking arithmetic series like this, they're not going to give you a problem where you can't solve it. It's not necessarily true that just because you have two equations and two unknowns, you can solve it. I can't solve this, even though I have two equations and two unknowns. I don't really have two independent equations. My second equation is the same as my first. So the first gives me an infinite number of solutions. Adding the second doesn't help. I still have an infinite number of solutions.
I've got one more question for you.
Okay?
So find the partial sum, and then...
Find the what?
Find the partial sum.
Okay.
And then sigma k equals 1 11.
Whoa, sigma, k equals 1 to 11.
And then 2/3 k plus 4.
Like that, or the k plus 4 in parentheses?
It has the whole thing in parentheses, so yeah, I like that.
It's like this?
Yeah.
Okay, the partial sum means the sum of the first n terms. What is it? What's this?
N over 2 parentheses a to the first plus a to the n, a sub 1 plus a sub n.
And they wanted the sum of how many terms?
11.
Okay. Well, first of all, we know what what is a sub 1? In other words, we need to know what a sub 1 is and what a sub n is. So what's a sub 1?
It's 1.
Well, it's 1 for k, which gives you 2/3 plus 4, right?
Yeah.
Okay, so 4 and 2/3 is a sub 1. What's a sub 11? Because they want s sub 11, so we need to know what a sub 11 is. Well, plug in 11 for k.
And then you get 2/3 of 11,
So that's 22/3 plus 4.
Plus 4.
Which is what? Let's put everything in thirds. So this is 30, let's see, that's 12 34/3. This one is, 4 is 12/3, 14/3. Okay, so now plug in everything. What is S sub 11? What's N?
Sorry. N is 11.
Right there. N is whatever the subscript on S is. So it's 11 over 2. And then a sub 1 is 14/3. A sub n is 34/3. I should say a sub 11. And your answer is going to be whatever you get when you do that.
Yeah.
So this subscript, when they want partial sums, in other words, this could go to infinity, wouldn't matter. Okay? Even if it went to infinity, they might want to know what S sub 11 is. But before I can answer that, I need to know what A sub 1 is and A sub 11.
Yeah. And so you can find all of those just by plugging in the term for k?
Yes. Exactly. In other words, the first term is when k is equal to 1. The 11th term is when k is equal to 11.
Yeah. And then so my last question is we just did today where I got the bottom of the sigma, it was equal to 1. it's equal to something else.
It doesn't, yeah, it doesn't have to always go from 1. You can actually go from 0 if you want. In other words, I could go from 0 to 11. Now what's the first term?
4.
Yes.
So it just changes what you plug in.
Well, these sigma notations can do a lot of things. In other words, they can go from 2. I could go from 2 to 12. Okay?
And then, yeah.
And the reason I might be going from 2 instead of 1 or 0 is, let's say I had the log, or 1 divided by the log of k. Well, notice that if I had 1 over the log of k, k could not be 0 because you can't take the log of 0. And k can't be 1 because the log of 1 is 0, and that would cause me to divide by 0. So I would have to start my sequence at 2. That would be the only place I could start my sequence, would be from k equal 2. Because the function isn't defined when k is 0 or k is 1.
So then there would only be 10 terms, and it was like find the sum of that.
Actually 11 terms. This would be 11 terms. Notice that it's the two numbers subtracted plus 1. In other words, notice that if I go from k equals 0 to 2, that's 3 terms, not 2.
Yeah.
So if I'm going from 2 to 12, that's 12 minus 2 plus 1 terms. If I'm going from 0 to 11, that's 12 terms.
I get it.
Good. Anything else, or are you good to go?
I think I'm good to go.
All right, Max. Nice talking to you again. I'll talk to you next time.
Yeah, thank you.
You're welcome. Bye-bye.